So we can now compare this to a Java application, right? So I have I started my NetBeans environment, so I'm just going to create new project, right? Create new project. And so similarly, we will demonstrate it for our course right here. So we're going to say CIS 260 over here. And we're going to name this project aggregation. Call this project aggregation. I will create the main class, and I will, as usual, I usually give it a recognizable name like this, and I will finish this now, and basically go to my project. Let me close this one, which I don't use today. Right, so we have this aggregation example in main class. I'll just get rid of Java docs at this point on. And of course, in Java, classes cannot be written in directly in the same file. Like I had only one single file where I've written pretty much everything. Class engine, class wheel, class scooter were all placed in one single file. Whereas over here, in Java, of course, I have to do things separately. So I just will go to my aggregation package and say new Java class name scooter, right? Create that. Okay, so I will create this class, and then I will similarly I will create a class named engine, right? I create class name engine. Okay, so if you so we'll just basically try copy and paste as much code as we can from our C++ demo, but at this point we just need placeholders for these. And of course we're going to also have a wheel, new Java class named wheel. Okay, so we're going to use that. Okay, so we've got that. So now we have all parts so far. So in the scooter, again, we're going to essentially take as much as we can. So those were the internals of the scooter class in C++. I'm just going to copy and paste this into my scooter class right here and just paste this in. Okay. So of course in Java we have to provide different syntax, so we cannot do it this way. Already wheel is an array. We're going to create an array of wheels, okay? And engine is just no longer an actual object inside the class. This is just a reference to the engine. So the initializer list does not exist for in Java. Instead, we need to call the actual constructors, right? So we're going to say engine, right? And the engine will take the type of the engine, I suppose. And in Java, we just absolutely have to say new, because every object is created by new, right? So likewise, we're going to say that wheel, right, equals new, and we're going to construct the wheel as an array of two wheels right here, right? So just gonna have to create that, and then more so, we have to populate each wheel, like the initial object, which has index 0, has to be saying new wheel, right? We have to actually constructed using the constructor syntax. Every object has to be populated, right? And then because remember that this creates array object of two elements, right? Two elements of specific type, but these two elements are object references. They're not objects, right? And so now create first array element, right? And create the second, and create the second array element. In Java, we have to do this as separate steps because we have to use new all the time. And so the engine is another class that has code on our in our C++ example. So we're going to copy this and paste this right here. Okay, so the integer type over here, of course, we need to specify that this is a private, right? Private integer type. Constructor, of course, is public, but here it goes through the specifier like this. We're going to pass in the type, and I guess in Java we don't have, we can use just the same name like this. And we're just going to say this type equals the type that was given to this constructor, right? So that would be my adaptation of the engine, the internals of this engine class moving from C++ to Java. The wheel remains the same. I think that everything that we have so far seems reasonable. Okay, and then in main we can create the scooter, right? So in main, as before, I'm just gonna say scooter, and again we have to say new scooter, right? And we do have default constructor for this class. All right, so let's save everything. Let me just build this just to see if I'm missing anything, just to make sure that everything looks okay. Right, we're just going to build initially and see what the compiler tells me. Maybe I'm missing something, so just make sure that everything's fine. Yeah, I forgot. Oh yeah, I didn't change the syntax right here, right? So I just need to change the syntax to say public, and perhaps these should be private, right? Private engine and private wheel, to be consistent with the design guidelines that we normally follow, right? Okay, so if I go right here, and this time maybe I will have better luck doing this. Maybe I'm missing something else.
Inside your main class, you didn't have the object.
Yes, inside my main class, right here, I need to name it exactly, right? So I just moving over, and I have to name it. So hopefully now things will be better, right? So my output looks better this time. So the build is successful. So we adopted this idea, right? So if we go back to this object diagram and the idea of composition is not possible in Java because everything has to be created by new. So I will simply essentially grab this portion here and push it down, right, with this idea of composition, and hide it down there. So in Java, the only possible type of work is to say aggregation. Aggregation, which equals essentially equals aggregation by value, by reference, right? Compared by reference. What it means is this: the first thing that happens in this Java application is that we create new scooter, right? So we create the new scooter, and so the scooter constructor executes, right? So it executes right here, and we're about to construct the scooter, okay? And we are saying new scooter, okay? Then new engine is created because we say in our constructor for the scooter, the first thing that happens here, we say new engine, right? So the engine this time is created outside of the scooter box. It's impossible to keep this object right here inside. The only thing that's going to happen that the constructor for this engine box is going to execute, construct the real object, and what we get back is a reference over here. So that's why we say aggregation is really aggregation by reference, whereas composition is aggregation by value, a much stronger version of the aggregation. Then, of course, what happens is that we construct on the next line right here, we construct an array of two wheels. But remember, in Java, arrays are arrays of object references, right? So they're really small. They will be providing space for two object references. And then eventually we say construct one wheel and the second wheel, right? So the two wheels will be constructed right here, the first one and the second one, and there constructor returns back a reference which we capture in our array, right? So this is comparison between the Java memory management compared to C++ version that we had, right? So it's very different. Here everything is apart. Logically everything is linked and still provides means for aggregation, because we can use constructors of our objects to control creation of objects. And by the way, in that case, by the way, the diamonds switch back to non-filled because these diamond shapes are only indicating aggregation, right? So we say it's not by containment, it's a weaker version of aggregation just by containment. So the diamonds are not filled, okay? But still, this part over here, the actual the whole part, right? Something that we said, the whole part compared to the parts that we're trying to manage here, this would be an aggregate object which aggregates other parts, right? And so these parts are over here. This is the engine box, supposedly, right? Of course, for the most primitive version of collection here would be using the array object and having it hard-coded to two elements immediately as we created, and then of course populating it with these two. So that's your overview of aggregation in Java, and stronger version of it which is referred to as composition in C++. And you have quick examples of both in this segment.